Alright, in this lesson you're going to learn about perfect squares. So perfect squares are these two formulas. We're going to prove it. So these are called perfect square because it's something square, they are called perfect square. They can be expanded by writing a plus b twice, and you just do the arrow. So you go a square plus ab plus ba plus b squared. But because AB and BA are the same, you get A squared plus 2AB plus B squared. And same for the next one, A minus B, you will get A squared minus AB minus BA plus B squared, which also is negative 2AB plus B squared. So one has a negative in the middle, one has a positive. You should memorize these formulas rather than doing this arrow each time. So we're going to show you how to use the formula. So you're going to use this formula, a squared minus 2ab plus b squared. So that's your a, so you write 3x squared minus 2 here, 3x, and the b is the 2y. Notice that I just put a minus sign here. 2y is just the b. Okay, so that's your a minus b plus 2y squared. And now you just have to simplify it. Make sure you square the 3, and then you have to times all of these together, which is 12xy plus 4y squared. Okay, and then what you do is next one, 4x squared plus 2 times 4x squared times 5 plus 5 squared. Okay, same thing. Remember to square the 4, which is 16x power 4 plus 40x squared and then 25. So make sure you memorize these formulas, and they are not on the formula sheet. Make sure you memorize them. Alright, next is the difference of two squares. Again, have a look at the formula. It's different from the perfect square because one has a minus, one has a plus. And when you times them together, you get the difference of two squares. Let's prove this, why this is the case. So you get a squared, ab minus ba minus b squared. And then ab and minus ba, they cancel. That's why you don't have the 2ab like before. Right? It's cancelled. And then you end up getting a squared subtract b squared. That's what you get. Right, so we can use this formula. So you need to recognize whenever you've got a minus b and a plus b, you can just square the first minus square the second, which is just 4x squared minus 9. And same thing for the second one. Difference of two squares, it doesn't matter which one I write first, the minus then the plus or plus the minus, you get the same formula. So you square the first minus square the second, which is 9x power 4 minus 16 is your final answer. Okay, so on this page we demonstrated the perfect square formula as well as the difference of two square formula. Alright, then we'll move on to some harder questions to do. These are harder ones because it has got fractions, so it doesn't matter. You can just go t squared plus 2ab plus b squared. Right? And then you see the cancellation of the t's, which you end up getting just the t squared plus 2 plus 1 on t squared. Okay, what if it's minus? It's exactly the same thing. You get t squared minus 2t 1 on t, and then plus 1 on t squared. And then you end up getting 2. So you get t squared equal. Alright, that's a perfect square. And feel free to pause or rewind this video. Next, that will be difference of two squared because it's a plus b here and a minus b. And your result was going to be a squared minus b squared. So you go t squared minus 1 on t squared, which results in t squared minus 1 on t squared. Alright, and then there's some harder expansion. So you're going to square the first one, x squared plus 10x plus 25. Right, the perfect square. and then minus 3, and then you do this expansion, which is a difference of 2 squared, and then you have to expand the negative 3. So you get x squared plus 10x plus 25, and then you get, and then you get negative 12x squared plus 3, and you get negative 11x squared plus 10x plus 28. Alright, collect like terms. And what if we have a different one look like this? So you just draw the arrow. So no special formula. So 3x cubed minus 6x squared plus 15x minus 4x squared plus 8x minus 20. Oops. Doesn't work. Try again. Okay. Alright, so we've got that, which is equal to, so collect like terms, 3x cubed. These two are negative 10x squared. These two are 23x minus 20. Alright, we've done all the special product. Again, I did it very fast. Feel free to pause and rewind this video. Okay, so that's done, and then we'll go on to the next page. There's some harder expansion, which I can show you. So this is true. What if I want to square that? So all you have to do is just write them as a double bracket, and then you just go x squared, xy, xz, and then you go yx, y squared, yz, and then you got zx, zy, z squared. And you just have to collect like terms. So it looks like they put all the square term first, plus y squared plus z squared. So if I highlight these, so they wrote these first, as they wrote here. And then there's some like terms. So can you see that xy and just written in different order, x, y, x are the same. So you can write that as 2xy. And there's exactly 2 of these for the xz, and exactly 2 of these for yz. Yeah. So let's write them all out. So there's 2 lots of xz and then yz. Yeah, which is what they got here. Alright, we'll prove this. What if you have cube? How do you do if it's a cube? So you just have to go square times, actually, just write a minus b square. So when you do cube, it's same as this times that, and then you just go a minus b to the left hand side, and then you square this, which is a squared minus 2ab plus b squared, and then you expand more. Then you have to do arrows, so you get a cubed minus 2a squared b plus ab squared minus ba squared plus 2ab squared minus b cubed. And then you're going to collect like terms. So these are like terms. They both have an a squared and b, so b minus 3a squared b. These two are like terms, so you get 3ab squared. And then finally you only have a negative b cubed at the end, and also a cubed in front. Okay, so that proves this question. And then we've got one more. Let's try with this example. So same thing, left hand side equals to 2x plus 5, and then 2x plus 5 square. So you get 2x plus 5, 4x squared plus 2 times 2 is 4, 4 times 5 is 20, x plus 25. And then you're going to times it together, so you get 8x cubed plus 40x squared plus 50x, and then you go to the 5, which is 20x squared, 80x, and not 80, 100, 100x, and then 5 times 20, 125. And you collect like terms, ax cubed plus 60x squared, which is these two, and then you got the 150x, which is this, and then finally 125. Right, these are all the possible expansions you could get in the exam. So make sure you practice these and do the question from the textbook. And the last thing we're going to do today is the common factors, factorize common factors out. So factorization is opposite of expansion. So we'll take the common factor 5, so that becomes 5a minus b. Because if you expand this, 5 times a is 5a, 5 times b is negative 5b. So it's the opposite of expansion. This one you do this, 2x, x plus 3. Okay? Because 2x times x is 3x squared, 2x times 3 is 6x. Right, and then there's some slightly harder ones, so you get 6m squared out, 2 plus 3m. And finally, this one, there's a common factor, which is x plus 3, and then you got 5 plus 2y. Okay, alright. Next, we can group in pairs. So these two have a common factor x, these two have a common factor y, and then they both have a common factor of a plus b, and put the x plus y inside. Alright, this one, same thing, a, b plus c, and what if there's nothing? You just write 1, b plus c, and then b plus c is common, a plus 1. Okay, alright, next is this one, so you take the f out, so f is common. And then you see there's a negative here, so you take the negative f out, but be careful, actually not negative f, negative g out, g is common. And write positive f but minus 3, because negative g times negative 3 is positive 3g. And then you have this common factor, and then f minus g, right? Okay, and then lastly you take a out, m minus n, and then you take the b out, n minus m, but then there's a problem because they look different in different order. So what you do is, let's switch the order, so you write a, m minus n, and then b, and then you write negative m plus n, like that, right? Negative follows the m, but then they're different. So what you do is you can take a factor of negative out, which becomes this, n, like that, and then you get a, m minus n, so you take these two as common, and then that will be your final answer. Okay, so that's a quick review of what you did in year 10 up to simple factorization. Right, so there's 4 exercises you could do over the weekend, and there's also swimming carnival on Monday, so you have plenty of time to finish. So I see you on Tuesday then. Okay, let's finish this.